Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Okay, so today I will continue our lecture, discuss about the motion detector. Alright, so previously we already discussed on the position level sensor, right? Okay, so basically there is two terms that you need to clarify, which is between occupancy and motion detector. Okay, so first is I want to tell you about the occupancy, which is the occupancy sensor, which is usually used to detect the presence of peoples or animals or anything in a monitored area. Okay, whereas for motion detector, it's only respond only to moving objects. Compared to occupancy, it detects on the stationary objects in presence in the monitored area, but in motion detector, it's only respond to the moving object. Okay, so the difference between these two sensor is that occupancy sensor will be produce signal when object is stationary or not, and then whereas the motion detector it's only sensitive with the moving objects. If the object is inside the room, for example, but it's not moving, the motion detector will be not respond to that things. Okay, but it will respond to the occupancy sensor. So that's the difference between the occupancy and motion detector. So you need to clarify and clear about these two terms, which is occupancy and also motion detector. Okay, so the application of this sensor is usually used in security, energy management, for example, to control electrical line, personal safety, or as a friendly home application, interactive toys, and others. Okay, so it depends on the application of the sensor that where we want to use. So usually the presence of human, it can be detected at the through of the properties of the human body, for example, the human temperature or the human action. Okay, so it's sometimes the detector also will be sensitive to, for example, to body weight, to heat, sounds, the electric constant, and others. Okay, so there are three types of sensor that we will discuss in this chapter, which is first is ultrasonic, second in microwave, and the last one, what else? The last one, if I'm not mistaken, is about the optoelectronic motion detector. Alright, so first of all, I will discuss about the ultrasonic motion detector in this part. Okay, so ultrasonic motion detector is based on the transmission to the object and receiving reflected acoustic wave. Okay, so for non-contact distance measurement, it's an active sensor, which is it transmits some kind of a pilot signal and receive reflected signal can be designed for the sensor. Okay, so the transmitted energy, it may be in the form of any radiation, for instance electromagnetic, which is in the optical range, electromagnetic in the microwave range, acoustic, and others. Okay, so the transmission and reception of the ultrasonic energy is a basis for very popular ultrasonic range meter and velocity detector. Ultrasonic wave is one of the mechanical acoustic wave, which is it's covered from the frequency well beyond the capabilities of human ears, which is over 20 kilohertz. Okay, but this frequency it might be perceived by small animals, for example, like dogs, cats, rodents, and insects. Okay, so how the ultrasonic motion detector workings. Okay, so when we have a wave that are incident and an object, so of course part of the energy will be reflected. Okay, so in the most practical cases, the ultrasonic energy, which is it will reflected in a diffuse manner that is regardless of the direction from which the energy comes. Okay, so it's reflected almost uniformly within a wide solid angle which may approach 180 degree. Okay, for example, in this figure, we have a transmitter which is we transmit our signal. Okay, here. Okay, and then this is our object. Okay, from here, when it's transmit to the object, and then some of their energy will be reflected back to the receiver, right? So when the object move, of course the frequency of the reflected wave will be different from the transmitted wave. So this is what we call as a Doppler effects. Okay, so the distance to the object we can calculate by using the equation of this one, which is L0 is equal to Vt cos theta divided by 2, which is T is the time for ultrasonic wave to travel from the transmitter back to the receiver, which is this is the time taken from here to here. Okay, and then theta is the angle when the transmitted wave from here, that one is the angle that we are measured. Alright, so when the transmitter and our receiver are positioned close to each other, which is closely to each other. Okay, so the of course the angle will be smaller. Okay, so the angle will be cos theta will be equivalent to 1. Okay, so compared to the microwave, ultrasonic wave, they have more advantage, which is why? Because the ultrasonic wave, they can propagate with the speed of sound, which is much slower compared to the speed of light. Okay, so we know that the speed of light is 3 times 10 power of 8, right? Okay, so it's the speed of sound is much slower compared to the speed of light. So so that the time is much longer and its measurement can be accomplished easier and it will be less expensive. To generate any mechanical wave, okay, including ultrasonic, the movement of a surface is required. Okay, so it's this movement creates compression and expansion of a medium, which can be either in the gas, liquid, or solid. Okay, so the most common type of excitation device which can generate surface movement in the ultrasonic range is a piezoelectric transducer. Okay, as we recall back what's the function of piezoelectric, which is we have pressure that on that things on the piezoelectric element, and then it will be generate electric, right, on the voltage. Okay, so so we know that piezoelectric is a device which is it will directly convert our electrical. Okay, sorry, there is some technical issue. Alright, so okay, we know that piezoelectric element convert electrical energy into the mechanical energy, right? Okay, so if you look at this figure, we have input voltage, which is is supplied to the our ceramic element. Okay, so when we apply this input voltage to the ceramic element, it will cause this piezoelectric ceramic element to flex and transmit ultrasonic wave. Okay, so piezoelectricity is a reversible phenomena which is the ceramic will generate voltage when incoming ultrasonic wave flex it. Okay, so in other words, the element may work as a transmitter and the receiver, which is as a microphone. Okay, so the typical operating frequency of the transmitting piezoelectric element is near to 32 kilohertz. Okay, so for better efficiency, the frequency of the driving oscillator should be adjusted to the resonant frequency of the piezoelectric ceramic as in the figure B, where the sensitivity and the efficiency of the element is the best. When the measurement circuit operates in a pulse mode, the same piezoelectric element is used for both transmission and also receiving. Alright, when the system required the continuous transmission of ultrasonic wave, separate piezoelectric elements are employed for the transmitter and receiver. Alright, so if you look at this last figure, okay, it's a typical design of an operating in air operating sensor. Okay, so if you look at the second figure, okay, where when the directional sensitivity diagram is important for a particular application. Okay, so if the directionality is more narrower in the diagram, it means that the sensor is more sensitive to the is a very sensitive transducer. Okay, so this is the directionality sensitive diagram of this sensor. Alright, that's all. Thank you.